Good day. Now we're going to take a look at another application problem of integration. We're going to be using integration to find the area between two curves, or that's the concept we're going to be talking about. This is an application problem to finding the area of a cross-section of an airplane wing. Okay, so that's what we have right here is the cross-section of an airplane wing. And we notice that we've got measurements of thicknesses every 20 centimeters. The length of the entire cross-section is 200 centimeters, and every 20 centimeters we have a measure of the thickness marked here. So what we're going to be doing is estimating with this information the area of this cross-section. Okay, so just kind of to get an idea of what we're doing, we're thinking of this area literally as the area between two curves. So we're thinking of the top of the cross-section as one curve, and the bottom of the cross-section as a different curve. So if we call them F and G, then we know the area between these curves would be, again, we're thinking of X as the length of the cross-section, so it goes from 0 to 200, or I could say X. We're thinking of X as the distance from the left end of the cross-section. Then we know that this integral would tell us the area of this cross-section, the area between the top curve and the bottom curve. And so that's what we're estimating here. We're going to estimate that using the midpoint rule. So we need to have this divided up into into equal intervals, and we do equal subintervals. We have this 200 centimeter cross-section divided up into 20 centimeter pieces. However, we're using the midpoint rule, which means we need to know the thickness of the cross-section at the midpoint of each of our subintervals. So I cannot use all 10 subintervals because then I would need to know the thickness in between these lines that we have measured, okay, halfway in between, and I don't. So remember, when we use the midpoint rule, what we're using is what we're using in our Riemann sum. That tells us to do a Riemann sum. In this case, we're doing the area between two curves, so we're doing the Riemann sum of a difference between two function values times delta x. Okay? And I use x sub I bar to indicate that I'm using the midpoint of each subinterval. Okay? So what I need to know is the function values at those subintervals in order to find this. Now, in our cases, in our situation, we're not actually finding values for f and g because what we're looking for is the difference, and so the difference between f and g is the actual thickness at that point. So we're not going to be doing any subtracting. The subtracting is already done for us in this case. So we cannot use all 10 subintervals because then we would not have data at the midpoints. So we can use, the most we could use would be 5 subintervals. So this is what we're actually going to be finding theoretically. That's the concept behind what we're doing. So if I have 5 subintervals, that means I'm dividing this up into subintervals every, let me grab a different colored chalk. I'm dividing this up into subintervals every 40 centimeters. Okay, so that I have the values I need at the midpoints. So we see the midpoint thicknesses are the numbers that are all written lower. Okay, I had to stagger to fit them all in. So these numbers that are written lower are the thicknesses at the midpoint of each subinterval. And so these are the ones we're actually going to use. Again, we already have the top minus the bottom. It's built in. We already have that distance. So we don't have to subtract anything. All we have to do is take those 5 numbers and add them up. And that's the first step in our Riemann sum. Okay, so I've got 20.3 plus 29.0 plus 27.3 plus 20.5 plus 8.7. And then I need to take that times my delta x, okay, which is the length of each subinterval. So that's my 40 centimeters, 200 divided by 5. So from here, it's just the calculations. He's at 48. Oh, that's not right. Was at 47.6. My bad. So that gives us 76.6, 97.1, 105, 106, 105.8. Okay, that's what I get. Hopefully, that's what I got in my head, so if that's not right, then you can make the correction. And then I take that sum times 40. So that gives me 4,232. Again, all my measurements are in centimeters. This is an area approximation, so it's going to be square centimeters. So there's another application of using the concept of integration to find areas between two curves. In this case, we're not actually finding an integral, we're actually approximating an integral using a Riemann sum. So we could practice of two different things there. Areas between curves and approximating using the midpoint rule with Riemann sums. So there you go. Our final answer, approximation, is 4,232 square centimeters.